Hey, 20-2s. In this lesson, what we're going to look at is division of radicals. Now, this will be a little bit trickier than multiplying, but it's not that bad. Okay, just a couple of things that we need to look out for. First thing we're going to talk about is something known as rationalizing. What the heck does this mean? Well, here's what it means. In mathematics, we have common things that we like to do just so that we always express our answers in the same thing. So what the word rationalizing means is they're going to say we don't want a radical down in the denominator. So what we'll do without changing the value of this is we're going to multiply by 1 in a sneaky way. Because 1 is the only thing I can multiply by that doesn't change the value. But that doesn't get rid of that root 2 in the denominator, does it? So guess what I'm going to do? I'm going to multiply by 1 in a sneaky way. So I'm going to multiply by root 2 divided by root 2. Because root 2 divided by root 2, guess what, is 1. Okay, so now I'm going to multiply these together. So just like normal fractions, we multiply top with top, bottom with bottom, numerator of numerator, denominator of denominator. So square root of 2 times the square root of 2 is the square root of 4. But guess what? What's the square root of 4? 2. There it is. That is rationalized because there is no radical in the denominator. All right. Now, the reason why we rationalize really is because there was a time, or if I didn't have a calculator, or if I had to estimate, I don't know what 1 root 2 really is. I don't know. But root 2 divided by 2, for some reason, that's a little easier for us to kind of figure out in our head. So I know root 2 is about 1.414 divided by 2. So I know that's going to be about that. So really, friends, the reason why we rationalize is it helps us do estimations really quickly. Okay? So here we go. To rationalize, we multiply by 1 in a sneaky way. So to divide the following and rationalize, what I'm going to say first off is there's nothing I can divide. So just like with multiplying, we're going to go coefficients with coefficients and radicands with radicands. There's nothing I can divide here. So I need to rationalize. So I'm going to multiply numerator and denominator by root 3. Notice I didn't include the 5 because I don't care about that 5 there. I'm okay with that. It's the radicand that I'm trying to get rid of, right? So now I go 5 root 9, but wait a minute. Root 9 is just 3, isn't it? So it's 5 times 3, which is 15. There it is. Okay, so that one we couldn't do any dividing at all. All we could do was rationalize it. Whereas look at the next one. 3 root 8 divided by 7 root 2. Well, here, what I'm able to do is divide my radicands. So that's 3 root 4 over 7, because 8 divided by 2 is 4. Well, hey, look at that. Square root of 4 is 2. 3 times 2. Boom. So on this question, we didn't even have to rationalize. We could just divide, right? So every question is going to be a little different. But again, keep in mind your goal is to get rid of radicals in the denominator. All right. Here, these two. Put a big star beside these. If you can do these two, you can do anything in the unit. Okay, or at least in this section is what I mean to say. Hey, these are the tough ones. So notice our denominators are binomials. So what I'm going to do is on this one, when it's a binomial, I need to multiply by something known as the conjugate. The conjugate. And notice what the conjugate is. What I did is I changed the sign in between the 4 and the root 3. All right, why did I do such a thing? You're going to see right now. Okay, in the numerator. So it's a monomial times a binomial, so we need to multiply twice. So 4 root 3 plus root 3 times root 3, well, that's root 9, and we know the square root of 9 is 3. Now, in the denominator, it's a binomial times a binomial. So we're going to go, if you like to use the term FOIL, but you're going to multiply 4 times 4, that's 16. Then 4 times root 3, that's 4 root 3. Negative root 3 times 4 is negative 4 root 3. And then root 3 times root 3 is root 9, which is just 3, and it's negative. But here's the important part about what we just did. Look at the two middle terms. They subtract to 0. They cancel. So when we multiply by the conjugate, what we're going to do is the two middle terms will always cancel. And then in the denominator here, I'm just going to simplify. 16 minus 3 is 13. So I'm going to say that again. When we multiply by the conjugate, guess what happens? Our two middle terms will add to 0. Okay, let's try another one. So on this one again, I notice it's a binomial in the denominator, so I multiply by the conjugate. All I do is change the sign in the middle, start multiplying. So root 5 times root 6 is root 30. Root 5 times root 2 is root 10. And here, because these are conjugates, I'm going to be lazy. I'm not going to figure out what the middle two terms are. I don't care, because what do I know? Those two middle terms are going to go to 0. So all I'm going to do is I'm going to go root 6 times root 6, first times first. Well, root 6 times root 6 is root 36, and the square root of that is just 6. Then I'm going to do the last two. Root 2 times root 2 is root 4. Square root of 4 is 2. And it'll always be a minus because it's a positive and a negative being multiplied together. And my friends, there it is. Now, I do take a quick second to see if I could simplify any of my radicands, but there's no perfect squares that go into 30 or 10, so I cannot. That is my answer. Okay, so when we're doing radical division, what I want you to try is 1, can I divide first? That might make my life easy. If not, then we start to rationalize, and you may have to use the conjugate. And then your last step you're going to see is, can you simplify anything else? Right? Using those skills we learned in the last couple lessons. Okay, there it is, friends. I'll see you next time in equations, I think. See you later.